Can you guys on Zoom hear me?
Yes.
Okay, cool. So I already asked this in person, but on Zoom, how are you guys feeling about your test tomorrow? Valid? Fair? Heck. Okay, so I don't remember if has she said to you guys how she sets up the exams? Okay, so she sets them up so that you have probably like 3 to 4 pages of multiple choice and then 1 to 2 of like math for your response. Yeah, let me get everything ready. Okay, I don't have one with me, but yeah, that's how she's gonna set them up. So you typically math questions is going to be the for your response, but sometimes she'll do a multiple choice math question. Okay. Oh my God. So this kind of jumps around a little, and I'm sorry. Yeah. Okay, let's just start with number 1. What's Avogadro's number? What do you use Avogadro's number? You know what? Nope, that's the next question. Sorry. So let's draw out the mole train. So let's say we're starting with grams. Where would we go to? Moles. How are we going to get to moles? Not yet. Molar mass. What else can we go to? What was that? Molecules. She has formula units, but that's like molecules, atoms, whatever you want to call it, or whatever you're dealing with at that time. What do you use to get there? Avogadro's number. Okay. Dimethylamine is an organic compound that is a colorless and odorless gas. The formula is CH32NH, and there are 150.7 grams released into a room. How many molecules are present in this room? So this is very like reminiscent of how she would ask a question. She'll give you a lot of useless info. Sometimes she'll give you numbers that you do not need. And it's just up to you to determine what whenever you come across a question like this and it gets a little overwhelming because here's a compound you don't know anything about, you don't know the name of, you probably don't even know how to pronounce it because it's a long word, and that can throw you off. But just sort of like slow down and ask yourself, like, what is this question really asking me for? So what is this question asking for? Molecules. So we need to get here. And to get here, we need to have one of these things. And we have grams, so we can do that. So we're starting off with grams, 150.7 grams, CH3, 2NH. What's going to go on the bottom? Molar mass. So we have, for carbon, I'm going to do this over here. We have one carbon at 12.01. For oh, nope, that's a lie, that's a lie. Why is that wrong? Two, yeah, I messed up. We're going to have 6 hydrogens at 1.01 each. Nope. How many hydrogens do we have? 7. You could do it separately if you wanted to, if you're just going along. But if you want to condense. And then nitrogen, we have 1 at 14.01. Not on Canvas or on my website. That's where I upload all of the worksheets, all of the answer keys, and recordings that I'm behind on, but I'm going to get them all posted today because your test is tomorrow. I don't know. I'm never in the math building. Whoops. I just don't print them out. One, because I used to, and I'd always end up with a whole bunch left over, and it felt super wasteful and gross. And then also, they don't want us doing a bunch of stuff where like a bunch of people are contacting with the same thing. So, okay. What's the molar mass? What was that? Say it louder. What's going to go on top? 1 mole. On the bottom? 1 mole. And on top? Make sure you cross out your units. She will take off points for that. Yeah, you can do it separately. So I did not write it out, but that's bad on me. You totally should.
Yeah, like if we don't show like 2 times 12.01 is this plus that, like is she gonna?
I don't for sure know the answer to that. So on Zoom, she's asking if are you asking about this part or this? This? She's asking if Adams will take off points for this. I don't know. Whenever whenever I was in her class, I wrote down basically everything I could because I just wanted to make sure. That's my advice. Okay. Now we do some math. And how many molecules are present in this room? Mm-hmm.
I got you.
Okay.
I don't think that's.
She may take off like a point, but that number tends to like vary from person to person because it is like the last number is always, how do I want to say this? It's always inexact. It's not exact. You're rounding, and so things get a little messy. But in multiple choice questions, she won't put like 2.01202, like, you know, she won't put all of those as an answer choice. So if you're doing multiple choice, it'll be very obvious which one it is. On a test, if you're like 0.001 off, it shouldn't matter too much. She like, I don't know, she won't go out of her way to mess you up, but if it's a common mistake that people make, she'll put it there. So I'll put like 2 or 3, whichever you've got.
But like you said, worst case scenario, she takes off 1 point at the very end and we go from 100 to a 99.
Yeah. Yeah, like that's the cool part about partial credit is if you mess up a little, you're still going to get most of the credit.
Whatever.
So what is the percent composition of hydrogen in heptane, which is C7H16? How are we going to find this? What? Sorry?
Except part over whole.
Part over whole, yeah. Anytime you see percent, that really just means part over whole. And in this case, our part is the hydrogen. So we need to calculate that. That's 1.01 times 16, which is 16.016. And I'm just using all the numbers because I did in my head. But then we have to divide it by the entire molecule. So it's going to be this plus 12.01 times 6, or 7, sorry. What's the molar mass?
I got 85.07. Oh, yeah.
That's what I got. Did anyone else get 09? Yeah, okay.
Look, so what do we do for this when it's like different? I got one on 100.23, and then you got 100.9. That makes a difference.
So, oh, that's why.
Yeah, 60.16.
Yep. I just shouldn't be allowed to do math in my head. $23? Okay, cool. So what is the what on earth?
That's what I got.
Yeah.
Do we just always go ahead and do 2 decimal places to the right, or I guess 4 things when we're dealing with molar mass?
Whenever you're doing molar mass, always do 2 decimal places.
So then we do the same for the final answer,
Yes.
since it didn't give us.
Okay. Which of the following does, which of the following does change in, that should be in, wow. Sorry, this is going really sloppy. I did not mean for this to happen. Which of the following does change in sample size change? Which one? Intensive? Not intensive.
Extensive there.
Extensive. Because intensive properties are independent of the amount present. And density is an intensive property. That's really important to know.
Density is an intensive property.
Yes. Density is intensive. Is that what you're asking? Sorry. The math make it like so difficult. Okay. I don't know how to say his last name. Antoine is credited with first stating the law of conservation of matter. He heated a mixture of tin and air in a sealed flask to produce tin 4 oxide. How did the mass of the sealed flask and contents change? Correct. Does anyone else, like, I don't want to give it just yet, but you're right. No, you're good. So who reads this question and is like, what the heck is going on?
Yeah.
Okay, that's fair. This is what I mean. This is a question that I pulled straight from one of her old exams. It was multiple choice. I made it free response. So this is what I mean. She gives you all this background information and you don't need over half of it. All we need here is law of conservation of matter. How does mass change after a chemical reaction? It doesn't. It stays the same.
I looked at that and my brain just like stuttered.
Yeah, that's honestly, that's where chemistry gets most students, is not the content. It's they give you a question with complicated like chemical names and your brain just like wants to nope out of it. But you know it. You guys know this. You just don't know you know it until you filter it. Or like even like it doesn't matter who did it. It doesn't matter what's being heated. What matters is it's a sealed flask. We're asking how the mass changes after a chemical reaction. Yes. Very generally. So on Zoom, she was asking if you need to know the people, like as far as history. I would know the names and their experiments, and sort of the general discovery that it led to. You don't really need to know a whole lot, like they're French or English or whatever. Yes, just the experiments more led to. Yeah. J.J. Thomson was the electrons. Robert Millikan discovered the charge of an electron. Yeah. Okay, gasoline has about the same density as octane. If 250.0 milliliters of octane has a mass of 175.5 grams, what is the density of octane in grams per milliliter? Also, I'm just going to throw this out there. Most of these questions I pulled and tweaked a little bit from my old exams or my old quizzes, or even ones from last semester. So, yeah, so this is very, very much the type of stuff you'll see. So, what am I looking for? Density. What do you have to do to make sure you don't get credit taken off? Formula, triangle, whatever works for you. So we have mass and we have volume, and one's in milliliters and one's in grams. There's no other conversions we have to do here. It's just division. Huh? It's just the numbers, really. The unit for what density can be reported in just changes based on what she asks. So you'll either be able to tell because she'll ask you directly in the question, or all of the answer choices will be in one unit. So like if she gave you this, but all of the answer choices are in grams per liter, you would know that you have to convert to liter. Okay, what is it? Mm-hmm.
I got that. I got 0.7020 to make it 460. Or wait, no, it's 360. 0.702.
Okay. Why did I put the O at the end? For sig figs. Cool.
Wait, so is the 0 in between the 5 and the decimal significant?
Yes.
Because it's to the left of the decimal?
Mm-hmm. Okay. An energy drink is an example of a heterogeneous mixture, homogeneous mixture, compound, or pure substance. Homogeneous mixture. Why? It's a solution. That's another word for homogeneous mixture. But yeah, you look at it, it's made up of a bunch of different compounds, but you can't look at it and be like, oh, here's one molecule of sugar. Who is credited with theorizing that the atom is mostly empty space with a dense charge center? Through what experiment was this proven? Rutherford's gold foil. I think Rutherford is one of the more prominent ones to remember. She talks about him a lot. I've seen a ton of questions about him. And the other two were related to electrons. This one's really related to protons and neutrons. Okay, the number of protons identifies the atom. What is this number called? Atomic number. The section of the periodic table that consists of metals with varying oxidation states is called the transition metals. Okay, I'm going to tack on an extra question here because I didn't put anything on it, but I want to make sure you guys know it. The different families on the periodic table, the different groups, what are the main groups? Okay, what's group 1A? Two A? So these two sound super similar and it's easy to get them mixed up. The way that I remember it is alkali is one word and it's group 1A. Alkaline earth is two words and it's 2A. What is 6A? Not halogens before? Chalcogens, yeah. 7A and 8A. Noble gases. Newton is, I don't like Newton. She'll just call them noble gases, yeah. Okay. What is the empirical formula for the hydrocarbon hexane C6H14? C3H7. Is everyone on Zoom doing all right with all this? Okay, cool. Okay, how do you guys feel about nomenclature? Okay. Yeah. Will you?
She says it does.
Okay,
She
cool.
doesn't have to memorize anything. Just know how to use it.
Okay, cool. I couldn't remember. Classify the following compounds as ionic, covalent, or acidic, and then name. So this first one, what type of bond is this? Not ionic. What is an ionic bond? A metal and a nonmetal, a cation and an anion. How do electrons behave in an ionic bond? They're transferred, so they're not shared. What's the name of this? So let's break it down real quick. This 2, what does this 2 mean? There are 2 nickel atoms. That's true. But what else does it mean? That means this anion has a charge of -2. So what does this 3 here mean? Yes. So what type of metal is nickel? It's a transition metal. What's the super weird thing we have to do with transition metals and naming them? Roman numerals. So we're going to have nickel, 3, and what is that anion? carbonate. The number one mistake students will make in this is writing nickel 2 carbonate. So remember how you have to swap and drop to get that formula, and you have to swap and rise to reverse it. Okay, what about PO3? Covalent. What is a covalent bond? Sharing of electrons between two nonmetals. How would we name this compound? Phosphorus trioxide.
So I missed this on the quiz. I missed that question.
Okay.
Where it was asking about like naming. So if that had a charge, like if that was a polyatomic ion with a little, would it be phosphate or yeah?
But phosphide.
Phosphite.
Phosphite? Okay.
Mhm. Yeah, pentoxide. Um, ooh. So I don't know, but if you put that A there, I can guarantee she's not going to count off for it. I can't really guarantee, but I'm pretty confident that she will not. Okay, H2SO4. Yes. It's an acidic bond, and it is sulfuric acid. What if I asked you to give me the formula for sulfurous acid? So, are you guys comfortable with us versus ick? No? Okay, you may or may not have heard this in lab, or she may or may not have said it in class, but how I remembered it was, so when you have sulfate, it goes to ick because you ate too much and you get sick. Ick, sick. Okay. Write the correct formula for the following compounds. Lithium bromate. So what's the oxidation number for lithium? 1+. What about bromate? -1. What's the formula? O3. It would, if it were just LiBr, this is lithium bromide. And for this, the key is in the suffix. If it's a polyatomic ion, the suffix won't change. If it's just that ion, it's going to go to -ide. They can have 8 ite, I think there's some weird ones like cyanide is a weird one, ammonium. Oh, excuse me. The 8 and the ite are going to be for oxyanions, so any of those ions that have an oxygen in them. Calcium fluoride. What's the formula for that? CaF2. Dinitrogen trioxide. N2O3. Hydrochloric acid. It's just going to be HCl. What did I want to say about this one? So here's where the acids get kind of weird, naming acids. When it's with a polyatomic ion, notice how you don't have the hydro up here, right? Whereas here, when it's just a single anion, it's not polyatomic, it's a monoatomic ion, we put that hydro there. So you could do hydrosulfuric acid. What would be the formula for that? H2S. Drop the what? Sulfuric acid is,
Or is it not because it's a monoatomic?
because it's monoatomic, it's not. I'm sorry, I know naming sucks and it's really weird. So here. So if it's just one, like H2S, HCl, it's what we call this binary acid. So you put the hydro there, you put the base name, you put ic and acid. So it'll always be ic unless it's a gas, but don't worry about that right now. So H2S, sulfuric acid.
So then, like, would chlorous acid be the H and the ClO3 because it's polyatomic and you don't use hydro?
Wait, sorry, say that again.
So would chlorous acid be the HClO3? Because it's polyatomic, there's no hydro, and it's 8, so it goes to, would that be chloric acid?
That would be chloric acid. Chlorous would be ClO2. So these weird naming things, this part, 8 to ic, ite to us, comes into play when we have polyatomic ions. So if there's more than 2 atoms listed, you need to start looking at this. So that's why up here we have 1, 2, 3 atoms listed or elements listed. So we need to start looking at other naming ways that aren't this. But here, HCl, that's only 2, so we put the hydro on it. Okay. I'm sorry, naming sucks. No one likes naming. Okay, lead to oxide. What would that look like? Mhm.
Since both the charges are two, do you do the inverted formula or you make it just PBO?
Yep.
Instead of PB2 or 2?
Mhm. PBO. They both have. This one has 2 plus. This one has 2 minus. So those sort of cancel each other out. So you just put the. You just write it like that.
So those, the Roman numerals to the right of lead tell you the charge of oxide or oxygen, I guess, but, right?
They tell you the charge of lead.
Okay.
Yeah, when it's in the formula, it'll tell you the charge. Yeah. And lastly, potassium sulfate. K2SO4. Okay, wow, that was a lot of naming. How are you guys feeling right now?
Can you by chance explain really fast why it's K2SO4 and not just KSO4?
Yeah. So for potassium, hold up, let me get my periodic table. Potassium's in group 1, so it's going to have a K1 plus. Sulfate has a charge of 2 minus, SO4 2 minus. So you swap and drop when you make the formula.
Okay, thank you.
What was your question?
What is the prefixes for, like, if it's one more than a sulfate, like a per sulfate, what is that? Like, if there's one less than I, do you know what I'm talking about? What are the prefixes for that?
Yeah. Okay. More naming. So I'm going to start with chlorate. Let me grab something real quick. What's the formula for chlorate? So what if I had one less oxygen? Chloride. What about the charge? Stays the same. What if I had one less oxygen?
No, never mind.
Hypo, right? Can someone confirm that for me? Because I mix them up all the time. Hypo. Okay. I'm gonna box it in. There's an understood 1 here. You wouldn't write it out, but I'm doing it for these purposes. What if I have 4 oxygens? It'd be, oh shoot. Perchlorate. So this per comes from hyper, but we just shorten it to per.
That's when it says most oxygen, right?
That's one that has the most oxygen. So think about like, if you have a lot of caffeine, you're gonna get hyper. Like if you drink like, I don't know, 5 shots of espresso in one go, you're gonna get pretty freaking hyper. So you've had too much caffeine, too much oxygen here. For hypo, I don't I have to be honest, I don't have a trick for this one. I only have a trick for the hyper. Yes. Hypothermia. Ah, perfect. Thank you. Hypothermia. You don't have enough heat, you don't have enough oxygen, you're hypothermic. Does that help with the hypo? Okay, cool. So you'll base it, you'll decide when to use these based on the 8 form of whatever you're working with. Like literally just learn the 8s and you'll be totally fine, except for the ones that don't have oxygen in them. But I mean, yes. I don't know. For like integrity reasons, I can't see the exams. But definitely expect a few questions for sure. Yeah. Some people think that I like am like a TA or like I have some role in grades. I'm gonna let you guys know that that's not the case at all. I don't get to know your grades, any of that. I don't get to see the tests. I don't help make the tests or anything. So you guys, you're safe. Your information's safe. Okay, which of the following is an illustration of the law of constant composition? Table salt can be separated into other substances by a chemical process. Table salt is, there should be an is there, is 39% sodium and 61% chlorine by mass. Table salt and water forms a solution. Water boils at 100 degrees Celsius at 1 atmosphere pressure. And water and salt have different boiling points. It's B. Constant composition. I could have 1 gram of salt or I could have 100 grams of salt. It's still going to be 39% sodium, 61% chlorine. What was that? Yeah. So like if I had 1 gram, I'd have 0.39 grams of sodium and 0.61 grams of chlorine. If I had 100, I'd have 39 of sodium and 61 of chlorine. And you could mess with that. It's basically like a ratio, but the percentage is always going to be the same. If you divide part over whole, it should always come out to the same amounts. Okay. The molecular formula of a compound is always blank the empirical formula. Simpler than, an integral multiple of, the same as, more complex than, or different from. B. It's always some multiple, or the empirical formula times a number equals the molecular formula. The formulate of, how would you name this? Zinc perchlorate. Zinc 2 perchlorate, sorry. Yes, if it's a transition metal, you'll always do the Roman numeral. The per, so if you look at your flow chart, you have chlorate here, ClO3, and if you add one more, yeah.
So for that one, zinc, it has a charge like associated with it, but if it's like copper, will it just have like a charge in front of it in the formula? So it would be like
If it's
Cu2 ClO4 2 or something like that.
if it's copper, if they're giving it to you here, it would have a number here, and that would be your charge. Yeah. Like, fun fact, you don't really have to know this, but I didn't know this until like my second semester as a chemistry SI, which I feel like is really crazy. But these numbers here, these tiny little ones, 2 and 1, those are the possible oxidation numbers of that element. Fun fact.
Oh yeah, I remember.
And I didn't learn it until I started SIing for Adams. I took her class. I never, I don't know. I just threw that knowledge away. Okay, what's the formula weight?
How do you know when to use grams versus atomic mass units?
It just depends on what the answer choices are in. They're really interchangeable. But once you start doing dimensional analysis with like moles, then you'll want to do grams per mole. The only reason I didn't take this out to 2 is because I literally just stole this answer from a multiple choice question, and she didn't take it out to 2, so that's why. Okay. How many moles of water are there in 4.25 times 10 to the 24th molecules of water? So start with the given. Oh, shoot. What's going to go down here?
6.022
Avogadro's number. And what's going to go on top? 1 mole. Cross out your units and math. Honestly, y'all are doing really well. Like this. I'm going to say to go ahead and start putting the formula with it, because pretty soon, like probably in the next couple of weeks, we'll be going from one compound to another. You have to keep track of that because it'll get long and messy, and it's super easy to mess up. Yeah, I made this worksheet. This worksheet was supposed to last 2 hours. It's been like 1 and we're almost done. So I feel like you guys are pretty set for this exam because it took me forever to make this. Yeah, of course. Okay, what's the answer?
7.02.
7.06 moles. Moles H2O. Perfect. What do you mean? It's incorrect, but I guess you could do it if you really wanted to. Kind of like how when you're doing grams, you just put G. Yeah.
Hello. Go get her. Get her. I love when this happens. Oh my goodness. Did you just realize she's here?
I'm just glad I'm not a professor that doesn't know how to work Zoom. Like that one time Adam's just,
I love that. Like, I thought that was so funny.
someone was like they were like talking to whoever. I know. And she just like ended the entire Zoom meeting. I wish I could have told her that she could just go meet, but there's like a whole bunch of people on that Zoom. She probably would have just ended it anyway. Okay, a compound contains 38.7% potassium, 13.9% nitrogen, and 47.4% oxygen by mass. Determine the empirical formula of this compound. What's step one? Magic. We're just assuming that we have 100 grams of substance. So we have 38.7 grams of potassium, 13.9 grams of nitrogen, and 47.4 grams oxygen. What do we have to go to? What unit do we have to get to? Moles. So what's going to go on bottom here? Molar mass. What's the molar mass of potassium? 39.10 grams potassium to 1 mole. Nitrogen? 14.01 grams nitrogen. Sorry, I should be doing this. And then 16.00 grams oxygen. Cross out your units and do some math. Okay, I feel like you guys are gonna hate this, but this is what I do because it gets you the most accurate number you can possibly get. I write down every single number that my calculator shows me. Because I'm bad at like doing the whole storing thing, whatever. I'm really bad with calculators, really bad. So I write everything down to make sure I don't really screw up. I mean, if you've been doing things a different way and it works for you, you've been getting them right, no big errors, keep doing that. Do what works for you. But also when you're working on your calculator, make sure, that's wrong. Make sure you are not rounding until the very, very end. Because if you round before then, you'll get wrong answers. Okay, what's next? Divide by the smallest. So we're going to divide by potassium. I'm just going to write K because I don't want to write those big numbers out, except for here. This is going to equal 1. What's this one going to be? 1. And this one? 3. What's the empirical formula? KNO3. Okay, the molecular formula from question, or the mass of the molecular formula from question 19 is 404.40 AMU. What is the molecular formula? What can I do with this information?
Figure out what to multiply the empirical formula by, right? We had to do that last night. Yeah.
They divide
Yes.
that by.
So remember that molecular formula is a multiple of the empirical formula. So what we need to do is get the mass of the empirical formula. Molecular weight divided by empirical weight. Is going to give you your multiplier. And it's what you're going to multiply every single subscript by. So we have the molecular weight, 404.40 grams. What is the empirical weight? Sorry, my brain blanked for a second. If you divide that, what are you going to get? 4. So now we need to go through and multiply every single subscript by 4. So what is the molecular formula? K4N4012. How would you name that? No, I'm kidding. I don't even know how to name that truthfully. So just out of curiosity, how many people in here have to take organic chem? Get comfortable with naming. It's going to take up like the first month of your class.
Is OChem as bad as everybody says it is? You can be honest. It's not fun. It's less to do.
It's not fun. It was not my favorite class. I came out with a C. So. It depends who you take it with over the summer. I know some professors will move more quickly than others. Definitely, I recommend this for all of your classes. Just like ask around and see who's taken a certain professor and see what you think will mesh best with your learning style and like your pace. Yeah. OChem, it's not like miserable. I didn't have to take 2 though. I only had to take 1. So it's not totally miserable, and it's important, especially if you have to take biochem, because I'm sitting in biochem right now and he's bringing up stuff from OChem and I'm like, oh my God, I forgot all this. So it's important if you're taking that. Like it's definitely work. It's doable. You guys are all smart. I know sometimes we don't feel like it, but you made it to college. You're smart. Even if you didn't make it to college, you're still smart. But it's not for everyone. Not everyone wants to go through this. That's totally valid. But you guys are smart. Believe it. Because I think a big issue is students will like hear how terrible chemistry is, and then they go into it already to like think it's terrible and let it make them feel dumb. But like, but you guys are really doing great, like from what I've seen. So, okay, woo, last question. Which metal forms cations of differing charges?
I just found her Zoom.
What was that? I don't know if that was intentional or not.
The protection. It's just a protection.
Mm-hmm. 10. Why? It's a transition metal. That's all. And now that you know that thing about the small numbers on your periodic table, you can check and see which one of these has more than one. Okay, that's all. You can ask questions if you. Does anyone on Zoom have questions before I end the meeting? Oh wait, hey, don't leave yet, actually. There's more people here than when I started this, so please use this form, sign in, so that my department can do their statistics, whatever they do.
Was the whole session recorded?
Yes.
Awesome, thank you.
Leah, what's up? It's Leah, right?
Yeah, it's Leo.
Okay, cool.
Is there gonna be parts per million, parts per billion on the test?
It's on the review, so I don't know. I would assume, but
It should be on Canvas.
Okay.
I do not know the exact contents of the exam. Parts per million and parts per billion is really a Chem 2 concept that you'll use a lot there. So.
Okay, because for the homework, they were doing like this weird thing with the exponents. And whenever I got like an answer with like one kind of exponent, the question would say that my answer was wrong because they put the wrong one or something like that, but it kept changing what was on my calculator. It was weird.
One thing that I've learned assigning for this class, because this is like my second year doing it, is the homework is pretty much always more difficult, because the professors don't know what they're doing on the homework. They just check what types of topics they want the homework to cover, and it's just whatever Newton chooses to throw at you. So.
Oh, okay.
Yeah.
That was it. Thank you.
Tyler, what's up?
What all like formula things are we gonna like? I know we're gonna be able to use the periodic table, but are there any other sheets that we need to print out for the test?
You'll probably want to email her and double check, but I don't see why you wouldn't be able to do this. This chart is available to print off of Canvas because it's on the back of the periodic tables that they use. So. Oh.
And then do we get like new periodic tables? Because it's like write a bunch of random information on these.
If you're coming in person and if you're doing it online, still don't do that. But she brings her own copies to hand out. You can't use your personal one.
Wait, so what if you're taking it on Portfolio?
If you're using that, then print out the flow chart for naming, print out the periodic table, and use that. Yes.
Thank you.
Yeah, completely empty. I don't totally know how she's gonna do it. I don't. Yeah. Yeah.
You know, you're not like just looking at, you're like doing like work and stuff, you know. I'm gonna do it in person. I'm not gonna mess with that.
Yeah, if you're concerned about if you're concerned about that, like that you may get flagged or questioned, take it, just go and take it in person. It's like the easiest way. I don't know the answer to that question.
What if we have extended time and she said we can't do extended time in class? Because I'm still worried about getting flagged for cheating or using outside sources.
That is definitely something that I would contact her personally about.
Okay.
Yeah, and yes, we can do another empirical formula. Does anyone here have to go but have a question that they want answered? Yes. Aqueous? What do you mean? Like, so aqueous really just means dissolved in water. Yeah, so like salt water, if you mix table salt and water, that's an aqueous solution of sodium chloride. So that's all that means, yeah. Anything else? Okay, cool. I'm gonna do another empirical formula one. Whoa, what was I gonna ask? Do you mean like switching from empirical to molecular, or like using percentages to find empirical formula? Yeah, we can do both. Okay, cool.
I need to go so bad.
No. I personally have like walked out of an SI session before, so I get it. Life happens, man. Okay, so let's start with the empirical and molecular, and then I'll shift into naming more. Is there a specific section of naming that you want to go through? Okay. So acids, yes, we can do that. Shoot, I have to think now. Sorry, give me 1 second. Okay. And also, if anyone does have to go, you can go. You're not going to offend me, I promise. Ooh. Okay. Let's do this. Let's say you have a compound that is 26.56. Oop, that's not a 6. 26.56% potassium. 35.41% chromium. And shoot, I need my calculator. And 38.03% oxygen. And we want to find the empirical formula of this. So what is step 1? Magic. So we're going to assume that we have 100 grams, which means that 26%, like if we're leaving this off, 26% of 100 grams is 26 grams. So we have 26.56 grams of potassium, 34.41 grams of chromium, and 38.03 grams of oxygen. So what's going to go on the bottom?
Is it 3541 or 3441?
3541, sorry.
You're fine.
Thank you for that. I mess up when writing a lot, so if I really mess up, just let me know because it happens. a lot. So for this bottom portion, you're going to pull that number straight from the periodic table. So for K, it's 39.10 grams potassium. For chromium, I have to find it. It is, I'm gonna do 52. And then oxygen is 16.00 grams oxygen. Up on top is going to be 1 mole, because whatever you take off of that periodic table is equal to 1 mole. Cross out your units and do some math. So 26.56 divided by 39.1 is 0.679283875. Okay. For chromium, 35.41 divided by 52, 0.6809615385 moles chromium. And then 38.03 divided by 16 is 2.376875 moles oxygen. So what's step 2? Now we have our moles. What do we need to do? Divide by the smallest. So for this one, potassium is the smallest again. Okay. So for potassium, it's going to come out to 1. What about for chromium? Oh shoot, why did they do this one?
So you run it up to 1, but it's within the 0.2.
Yes.
So like say it's just 0.8. Does it have to be greater than 0.2, or can it just be 0.2 and up? Does that, you know what I mean? Like, so what if it's like 0.78? Would you round that up to 0.8 and then it's 0.2 away and then you're good?
I would not.
Okay.
Um,
So I did that on Newton a bunch of times.
can someone tell me if I totally messed up the percentages for oxygen?
I got pretty close.
Yeah, that's why I'm like. Because this answer key has 36.96.
Well, that adds up to 100. We have written up there, guys.
Oh my gosh. I should not have just pulled this off the internet. Oh my god. Okay. So, would it be mega confusing if I changed the grams just to make this work? Okay, cool. This doesn't add up to 100, but just ignore that because I was not expecting this to happen and I deeply apologize. Okay. Oh, wow, that still didn't make it work. Whatever. I'm going to say this is 3. It comes out to 3.4 moles, and that doesn't work. And I really need this problem to work. So we're going to call this 3 moles. Is everyone okay with that? Sorry, I feel like I'm like the messiest SI ever.
I'm fine with that. It's just on, not Canvas, on the homework, it had us multiply all of it by one number to get it as a whole number. Do we do that as well on the test?
Yeah, so like when do you multiply it by? It's like point lower than 0.8 or what?
Yeah, if it,
So if it's like 2.74, then you multiply it by something.
yeah.
Okay.
On the exam, I personally, on like the exams and quizzes that I haven't seen it to where she makes you do that.
Shit.
The homework will always give you a harder time, always. So then what is the, oh, so to answer your question, I would not worry about it because I haven't seen her throw that on an exam or quiz. Okay, so what's the empirical formula? KCrO3. Okay, what's the empirical weight?
No, 7.1.
I,
Oh, no, shit. $139.1.
yes, 139.1 grams. Or AMU, whichever. Huh? Yes, this is the empirical weight. So now I'm going to give you a formula weight of 1,251.9 grams. It's big. So for this, so you take the numbers right off the periodic table, the weight. So potassium, you have 1 potassium and the weight is 39.10. For chromium, we have 1 and it's 52.00. And then for oxygen, we have 3 and it's 16.00. So you come up with the answers for that and then you add them all up and that's your formula weight. Okay, so this is the molecular weight. Okay. What am I going to do with this? Divide. 1,251.9 divided by 139.1. What is that? 9.
What if it doesn't come out to be a whole number? Like, what if it's like 9.4, 9.3? Would you just round down and then if it was like 9.5 or up, then you would go up to 10? Or is it she usually not going to make it?
She's not going to do that to you. No.
There's
Okay.
Miss Cressy does that all the time.
So why did we just divide that? What is that giving us?
So this right here is our multiplier. And it's what we're going to multiply all of these subscripts by. There's an understood ones here. So if we're multiplying all of them by 9, what would be our molecular formula? K9, oh. K9, CR9 6O27. Does that make sense? Okay, cool.
Yes.
So then acids, naming acids. So really, you'll have this available on your exam, but it's definitely still good stuff to know, especially when you start moving up in chemistry or preparing for the final. On the final, it's not going to have the names. It's not going to have, you're not going to have the flow chart. And you're also not going to have these names. It'll just be the symbol. But I promise you'll know it by then. Okay. So when it comes to naming acids, so binary acid, bi meaning two. So you'll have H and then one other element. So if that's the case, honestly, you're not going to see a gas yet. So don't worry about that just yet. What do I want to do? Let's do HF. So this is a binary acid because there's only two atoms or two elements here. So anytime you're naming that, you're always going to start with hydro. And what would the rest of this name be? Hydrofluoric acid. Now, the other type of acid you can have is, where is it? Oxyacid. Ooh, okay.
It has like hydrogen, oxygen, and one more, right? Or is it-
Yeah, so this is going to be when there's a polyatomic ion there. So let's do, let's use chromate. So this is chromate, and we know because it has this 4 here. How would you name this? What does 8 turn into? Ick. So it's just going to be chromic acid.
And you don't use hydro polyatomic
Correct. No hydro because it's polyatomic.
because is chromate's polyatomic, or what if it was just like Cr? Then that would be monoatomic.
Yes.
Okay.
So she asked if it were just HCr, would it be monoatomic? And that's yes, that would be monatomic acid. Or monoatomic ion binary acid, sorry. I used to think it was funny when like my science professors were bad with words, but now that I've been in science for so long, I'm getting bad at words. So it'll happen. Okay, what if I had this?
Doesn't it go to ice
Chromite.
and it goes to OUS?
So this is chromite, which means it's going to be chromous acid. Does that help? Okay. Any other questions here? Yes. I wish I could remember off the top of my head, but I don't. No, the free response math questions will be worth more than the multiple choice. Yeah, it's worth more because I don't know if it calculates into worth more, but because of how she does partial credit, you have an opportunity to keep as many points as possible in them.
I have a question over, it's going back to empirical, but
Okay.
this one it asks, it says like, so it says I have a 150-gram sample of blank and it's comprised of blank, blank, blank.
Mhm.
So when it says that, do we multiply the percents first by that compound that they have and then turn everything into what I need to do, or what? Because I never know what to do with that
Okay.
compound that it gives me.
So does it have them listed as percentages?
Yes, ma'am. It says 150-gram sample of a compound is comprised of 44% carbon, 9% hydrogen, and the remainder is zero. I mean, the remainder is oxygen by mass.
Okay.
And then you
So
have
let
to
me
find the empirical.
just 47% oxygen. Okay. So think about how you get percentage. It's part over whole times 100, right?
Yes, ma'am.
Uh, So basically, how I would go about this is I would just go into straight up algebra. So let's say we're doing carbon. We have 44% carbon. It's equal to 100 times the part, which is our X, we're looking for that. And then 150.0 grams is the total. So divide by 100 and you get 0.44 is equal to X over 150. And then multiply both sides by 150 and you would get the amount of grams present in that sample.
And you would do that for every sample that gives you that amount like that.
Yes.
Awesome. Thank you.
Uh-huh.
So I was doing,
Mhm.
or I guess I was finishing the Newton last night, and there was this one section of it where you had to, it was related in some way to the mass to volume percent, where you had to do the part over whole times 100, but then there was some of them where, like, I didn't know if I needed to add to the total or not, and I'm trying to find, like, which module it was, because I, like,
Okay.
trying to find which one.
Is everyone on Zoom good? Okay, I'm gonna go ahead and end. Thank you for coming. Good luck on your exam.